For centuries, fortifications and fortresses served as the main form of protection for those on the defensive side and the main obstacle for attackers. In the 20th century, these constructions became obsolete. The final chord in this long-standing battle was played by a huge and remarkable German mortar named Karl-Grat. So why didn't Karl-Grat, Adam and other giant guns serve the purpose they had been built for? Mikhail Lapikov will tell us how the length of the barrel affects the gun's ballistic range and the devastating power of a 2-ton shell.
Construction of the Karl-Grat started in 1935 when the company Rheinmetall Borsig manufactured a super-heavy rifled mortar, which was designed to launch 4-ton projectiles over a 0.6 of a mile distance. Thus, the range of 2-ton projectiles constituted about 1.9 miles. The device was designed to break through long-term defense lines, including those of heavily reinforced forts.
The first mortar, named Adam, was produced in November 1940. Previously, in January, a heavy battery 833 was created, which included 2 batteries equipped with 2 guns each.
A small number of these devices were manufactured. In total, 7 devices were produced. 6 of them saw combat. In fact, Karl is not the official name of the device. It was nicknamed after its designer and just happened to stick. Thus, every mortar had its nickname. The first 2 were called Adam and Eva. The others were named after characters from Scandinavian mythology, like Thor or Odin.
The first thing that catches the eye is the size of the mortar. It's one of the largest self-propelled artillery weapons by caliber. Everything in it was unusual and unique, which made it terrifyingly legendary. A 21.2 inches and 23.6 inches gun, projectiles weighing more than 2 tons. Another remarkable fact was that the 23.6 inches barrel, capable of launching huge projectiles, was only 8.5 caliber long. The barrel was a solid unit, which had 112 grooves inside. Together with a breech, it weighed over 28 tons.
Depending on its type, a projectile weighing about 2 tons contained anywhere from 617 to 767 pounds of explosives, which can be compared to a sizable air bomb. And the impact points demonstrated the corresponding damage caused by its shots. 33 feet deep funnels and a sand cloud reaching up to 560 feet.
The self-propelled tracked chassis was a distinguishing feature of Karl-Grat. It allowed the gun to move independently, though its top speed was only 6.2 miles per hour. The front side contained a 580 horsepower engine.
To ensure its maneuverability, the mortar was placed on a self-propelled carriage. They even ensured the carriage was slightly armored to protect it against enemy fire.
But generally, Karl was transported by rail. The mortar was placed on 2 platforms and transported to its destination. It was often almost completely disassembled and then only reassembled at the front line. Transporting Karl to a war zone was hardly a subtle task, and the 16 crew members who operated the gun were supplemented by people who protected the mortar from the enemy. The mortar was armored mostly for the sake of reassurance. This wonder machine could be easily destroyed by the World War II classic tank T-34.
It was suggested that while on the site, the gun should be protected by special forces who otherwise did not play any part in battle. One could say that the defense of the Karl mortar wasn't effective enough if compared to its effect in combat. There was a need for AA gunners, communication support, and defense, depending on the presence of enemy forces. So, you can bet that several hundred people were engaged in the mortar's operation.
Using the mortar was rather demanding in terms of its operational conditions. Karl's horizontal aiming was performed by turning the mortar's mount only within a plus or minus 2.5 degree range. If a wider aiming range was required, they had to turn the whole chassis. Vertical aiming was within a 0 to 70 degree range. Aiming was performed manually. the shell's weight of over 2 tons should also be taken into consideration.
The rate of fire was 1 round per 10 minutes, its maximum rate. So, why was that? First, the mortar was quite difficult to reload after firing. Gun overheating was another major factor that should be considered. Additionally, if the mortar was loaded in haste, the shells became stuck in the gun, which proved to be a problem to its operating personnel.
The mortar was able to launch anti-concrete shells weighing 4,784 pounds, with a range of fire up to 2.8 miles. It could also launch high explosive shells weighing only 3,748 pounds, at a distance of up to 4 miles. The shells reached the speed of 722 to 935 feet per second. One could even see them slowly flying in the sky. Karl's gun was so large that it could theoretically fire shells the size of T-34 tank turrets, which weighed about 3 tons. Its battle performance would probably be just as formidable.
On the one hand, due to the huge destructive power of its high-caliber shells, they were able to severely damage a target. On the other hand, however, Karl's mortars did not play a significant role in any of its battles. The gun's main purpose turned out to be psychological, supporting German troops who felt more confident being covered by such a tremendous gun.
In 1944, during the Warsaw Uprising, these mortars were used to bombard the city. Karl's rounds were made purely for deterrence. There are pictures that show its shell bursting through a building, causing massive destruction, with debris scattered everywhere, icons of the horrors of war.
In fact, this behemoth with a huge gun and devastating shells was never really battle-tested. Its use was limited for a number of reasons. Historians have pointed out only 3 battles where Karl's mortars were used more or less effectively: the Siege of Brest Fortress, the Battle of Sevastopol, and the suppression of the Warsaw Uprising. Despite the lack of any significant service in battle, the Karl mortar is considered one of the most bizarre combat machines.
In fact, the Karl mortar is a typical German Wunderwaffe, wonder weapon, from a book. Huge, complicated, impressively designed, completely extraordinary, but absolutely useless in practice.
However, in terms of implementing military engineering projects, the Karl mortar deserves respect because its designers created a massive device, possibly only at that time. In other words, attempting to create something even bigger would have been impossible.